Hello, ladies and gentlemen. Welcome to Chapter 16. We are going to be talking about acids and bases, and this is the first part. I know that you have done some things with acids and bases in the past, so some of this will probably be review. However, some of this will most likely be new to you as well. If not on this video, then on one of the others. Okay, first off, let's talk about the properties of acids. The first characteristic is that they taste sour. In fact, that is how they got their name. Acidus in Latin means sour. Now, there are certain things that you are used to thinking about as acids. For example, with food. You think tomatoes, you think the colas, coffee, orange juice. These are things that you know are acidic. Oftentimes, if you drink orange juice on an empty stomach or coffee or something like that on an empty stomach, it actually can hurt your stomach. However, there are things that you might not think about when you think about acidic food. For example, broccoli, beef, corn, eggs, blueberries, milk, all of these things are also considered acidic, and some of them pretty strongly acidic. In fact, with milk, it has, the lactic acid and stuff in it. And you can think about the taste of these things, that they have a lot of the sour taste to them. Sometimes with things like blueberries or corn, you may have a sweet taste in combination with it, but it also has a bit of a sour. A lot of the meats are acidic, so things like beef, turkey, fish, chicken, these things are all acidic. And besides talking about foods and drinks that are acidic, things like aspirin are also quite acidic. A lot of people have stomach issues if they try to have aspirin on an empty stomach. Aspirin, by the way, was made out of willow bark. Nowadays, they don't take it from the willow tree. It's made in a laboratory, but it is from the bark of a tree. Okay? So these are things that would be tasting sour. Next characteristic is that most of these things are good conductors. Now, it is a bit of a misnomer. They say on this video that it's how to make a lemon battery. The reality is it is not a lemon battery. It is, however, a good conductor of electricity. The electricity actually comes from a chemical reaction between the lemon juice and the two different metals. But you'll see that it makes a good conductor.
When we think about batteries, we usually think about something that we pick up at the store and put in a clock to make it run. But sometimes the only battery you need is something as simple as a lemon from your kitchen. Which sounds crazy, right? But aside from being tasty, lemon juice is also an electrolyte solution, which means it produces a low voltage, about 0.9 of a volt per lemon. So if we wanted to light this 3-volt LED light, we need 3 volts, so about 4 lemons to make it work. Now, to create the circuit, we'd also need some zinc-covered nails, some alligator clips, and some medium-gauge copper wire, which you can get at a hardware store. Or you can use some of the leftover holiday lights stashed in the closet. The key thing is to create as conductive a circuit as you can. So once you've cleaned your copper wire and zinc nails to make sure they're more conductive, you'll stick a nail on one side of the lemon and a wire in the other side. Positive, negative. Do the same with 3 more lemons and set them up in a copper to zinc pattern so you can easily connect the alligator clips. And when you're ready to light your LED, fasten the copper side alligator clip to the longer positive end of the LED and the zinc side to the shorter negative end. And there it is, light! If your light's a little dim, go ahead and use a fresher lemon, or use the same number of lemons to help you calculate a little math. Either way, if life gives you lemons, you don't just have to stick with lemonade. When we think
Okay, so it is a fun experiment to do if you have lemons and alligator clips sitting around at home. Okay, the third property of an acid is that it turns blue litmus paper red, and you can see that. Okay, you see on the left, the litmus paper is what is considered a blue litmus paper. It's actually treated with part of a fungus to give it that color and that reactivity. Okay, however, if you dip it into an acid, you can see the dramatic change in color. Okay, it doesn't tell you how acidic it is, but it tells you that it is an acid. Okay, the next characteristic, the properties react with metal, and what you end up with is that it releases hydrogen gas and a salt. Now realize again, salt does not just mean sodium chloride. Okay, a salt is something else. Okay, so here you go.
Have you seen that sometimes when we accidentally spill some lemon juice on a surface, it leaves a stain? This happens because the lemon juice is acidic in nature and it reacts with the surface. Now let us see what kind of reaction occurs if acids come in contact with metals. We need zinc granules, which are metals, dilute hydrochloric acid, and dilute sulfuric acid, and a matchbox. We will put zinc granules in both the beakers. You will observe that zinc reacts with acids and releases a gas. What is the gas which is formed? Take the beaker containing dilute hydrochloric acid, light a matchstick and introduce it into the gas near the mouth of the beaker. You see that the matchstick burns with a pop sound when brought near the open end of beakers. Let's try it again. Take the beaker containing dilute sulfuric acid instead. Again, test the gas formed using a lit matchstick. Listen carefully for the sound. The pop sound is a clear indication that the gas involved is hydrogen. So when a metal reacts with an acid, hydrogen gas is released. In the first case, zinc combines with hydrochloric acid to form zinc chloride and hydrogen gas. Zn plus 2HCl will give ZnCl2 plus H2. In the second case, when zinc reacts with sulfuric acid, it gives zinc sulfate plus H2. Zn plus H2SO4 gives ZnSO4 plus H2, which is hydrogen. You can try this in the lab or at home with a metal like iron that is easily available. Take proper care while handling acids.
Okay. Unless you have parental permission, please don't try anything with acids. Okay, but you can see that the salts that were involved are not sodium chloride. They're not table salt. You have zinc chloride and zinc sulfate. Okay, so when talking chemistry, don't just think table salt when you hear the word salts. Okay, it's basically making a solid. Okay. So they will react, causing hydrogen gas, which is very flammable, and a salt. Okay, properties of bases. Bases taste bitter and feel slippery. Okay, you can see some of the foods that are considered that are basic, or sometimes you'll hear the word alkaline in reference to bases. Not all of them are things you would think of as bitter, like melon or apples, because they have so much sugar in them. However, when they are away from the sugar, you have things like onions and celery and asparagus. Those do tend to feel, taste bitter. Now, a very basic or alkaline substance is actually one of the main ingredients of soap, and that's lye, L-Y-E. That actually is why soap feels slippery, is it's reacting with the different tissues of your hand. The way you can kind of think about it is acids eat away at your skin, and bases just kind of make your skin slide off. Okay? If you've ever gotten bleach on your hand, bleach is a base, and you notice it feels slippery. If you get too much bleach on your hands for too long, what you'll notice is your hands will start looking shiny. And that is because the outer layers of skin are actually shedding. That is why it feels slippery, is you're actually losing skin. An acid will just kind of eat into your skin, and you'll end up looking kind of peely, like you have dry skin. Whereas the bases will actually take your skin and slide it right off. Okay, so if it's slippery, any type of soap or detergent, cleaners, and things that taste bitter would be considered bases or alkaline. Okay, and when it comes to litmus paper, there is a different litmus paper. There is red litmus paper, although you can see it looks pretty much pink. And when red litmus paper is put into a base, it turns blue. Okay, so the way you can kind of remember that is blue base, and then obviously what's left is the red acid, and you can think of it kind of burning. Okay, now if you take the blue litmus paper and you stick it into a base, it's just going to stay blue. If you take the red litmus paper and put it in an acid, it's just going to stay red. Okay, so it either changes color or does nothing. Okay, so those are some of the characteristics of acids and bases. We will talk more about them next time. So until then, have a good day.